Hello everyone, welcome back to my channel. In this video today we are going to install Kubernetes in a home lab. I'm using VMware Workstation Professional Free Edition and the operating system I'm using is Ubuntu. So this is the configuration of all the nodes, 4 gigabytes of memory and 4 CPU. So this is identical across all the nodes. The control CP is the control node. I have two workers, node 1 and node 2. So let's begin our journey. I'm using VS Code for ease. Now it's simple that we can go to this Kubernetes documentation and go through each and every step, but what I have done is I have put down all the steps necessary to build the Kubernetes environment in this script file. There are a few things that I have done to the nodes so that I can SSH into them. The first is I've assigned a static IP address to all of them. I've installed VM editor because we will be using to edit some files, and enable the SSH so that I can take SSH of all the nodes from my VS Code. Okay, so let's connect to our CP node. We are actually already on the, there you go, that's our CP node. Let's check. So the first thing we're checking is the default gateway is 1.1. This is my network, and the IP assigned is 1.50. This is a static IP that I have assigned. Let's begin our journey of preparing the control node. Now the first step is we have checked the IP already, so that's good. Now let's free up the memory, the swap memory F. So as you can see here, the swap memory is already disabled. Now we can also disable the swap partition by running this command. Go in here, enter. So as you can see here, the last section, which is swap img, is comment out. So that means we are no longer using the swap partition. So even if we reboot, the swap is going to be disabled, right? Okay, that's done. Now let's do this, which is, if you refer to this document, which I think I have it open here. So this is a requirement which is to enable the IP packet forwarding. So we are just going to run this section, which again I have copied in my script file here. So if we run it, so that is done. Now I can run this command, so the changes will be persistent without a reboot. That is done. So as you can see here at the bottom, IPv4 forwarding is 1. Let me clear the screen first. Okay, so that's the first step. We have completed few of the prerequisites, that is disabling the swap, followed by IP forwarding. Next is we will install our runtime. There are a couple of components that are needed on each of the node. One of them being the primary one, which is the runtime. So let's run this command, hit enter. Okay, this should not take much time. For now we will just stick to the control plane node. We'll finish it, and then once we move on to our nodes, worker nodes, I'll do side by side so that we can build both of them at once together. Okay, so our runtime, which is containerd, is installed. Let's quickly run the status check to see if the service is running and enabled. So there you go. The status is active and it is enabled. Let me clear the screen again. Okay. Right, now since we have installed the containerd runtime, the next is we have to create a configuration file. Now by default there is no directory created, so as you can see here, etc. Okay, no such directory exists, so we are going to create a directory inside our etc. Enter. Okay, now if I do, right, we have a folder created. The next is this command, which will go ahead and create a container the config file for us. There, okay, it's permission denied, no worries. So let me add okay, it still says permission denied, so let me see. Right, okay, how about now? Perfect. If I do ls, let's see, container D, there we have our config file. Now we're going to open this file in Vim editor. Right, so now there are a few parameters inside this default config files that we have to modify. So one that is system C group. So the default value is false. We are going to set it to true. Now I have this article which we can follow. So it has detailed information why we are disabling the system C group, enabling it by default. Okay. Right. So now in the VIA editor, let me copy this guy. Back to our editor. I'm going to look for that parameter. Okay, there it is, right? System CD. So default it is false, so I'm going to insert mode and set it to true. Okay, let's save this file. Right, so we have changed our system C group to default true. Now let's run this command to restart it. Okay, we have restarted our runtime. Now we'll just validate if the value is correct that we have set. So this command will tell us, yep, indeed our value is set to true now. So we have taken care of the container runtime part. Now let's move on to update the index. My bad, sorry. So we are going to run this command to update the index of our apt repository. Once that is complete, then we are going to install some of the prerequisites that are needed for Kubernetes, that is app transport HTTPS, CS certificates, curl, and GPG. Let me copy this command while this is done. Okay, our apt repository is updated. Now let's install the prerequisites. Hit enter. It should not take much time. This informations are all available in the Kubernetes documentation here. I've just gone through them and just put them together so that it is simple for us to run. Okay, next we are going to run this command. So what this command does, it is going to download the public signing key for the Kubernetes version package repository. Now here, if you see, the version of Kubernetes that we're going to use is v1.33. If we want to use another version, probably a lower version, because this is the recent, we have to remove this 1.33 and put in 1.29 or 1.21, whatever version we desire. Okay, so for now we will just stick to the latest version. Let me run this command, and that is done. Now the next is echo. So this is the command we are going to run. Let me clear the screen first. Okay, enter. So that's done. Okay, now we will go ahead and run the app repository update one more time since we have added the Kubernetes. Okay, perfect, that's done. Now we can run a command to check what is the version of Kubernetes available in our app repository. So if I do that, so that's the candidate or the version that is available for us to install. Okay, so now the next step would be to run the command which will go ahead and install the remaining 3 components. Okay, let me copy it again. Right, so as you can see here, there are 4 components that are needed primarily. One is the runtime, which we have already installed. After that, we have updated our app repository with the Kubernetes version, and now we are going to install the remaining 3 components, that is kubelet, kubeadm, and kubectl. Let's hit enter. Okay, perfect. So our 3 components, kubelet, kubeadm, and kubectl, are installed. Let's clear the screen and we will first run the status check for kubelet. Control C. So this is absolutely fine. As you can see here, the status is, it says inactive dead, which is absolutely fine and expected because we haven't added any worker node or any system pods are running yet. Okay, now let's also run this command to check what is the status of our container runtime. So that is still active, which is a good sign. Perfect, so we have installed all the components that are needed to build our control plane node. Now before we move ahead with initializing our cluster, we are going to run this command, which is also mentioned in the documentation, that is set a hold on the version of kubelet, kubeadm, and kubectl we have installed, right? So that when a time comes and there are new version available, we have a control in place wherein we can choose when to upgrade and when not to. All right, now before we proceed to upgrade, we have to unhold them first. Right, so we have hold a version that is 1.33. Now the next is, we are already as a root user, so we are going to run our command kube initialization. Let's run it. Now keep in mind that when you are building it, since it is an online thing that I'm doing, it is going to pull some images, system images, and create some system pods. So you need internet connection. There is a procedure for offline installation as well, but you have to use your local repository, I believe. I have not gone through that procedure. Probably I will read the documentation and create another video for that. For now, this is all online, so all the nodes have access to the internet. Okay, perfect. So now, as you can see here, our kubeadm initialization is complete, so our cluster is built. Now here are some of the pointers or steps that are needed in order to continue using it, which says run this so that regular users can use the cluster. So we are going to run this. over here. Perfect. So now if you see kubectl get pods, for example, no resources found. Let's do clear first, or let me stay in this screen and I'll open another session for this server. Yeah, that's better. Okay, so now let's run a initial command to check our cluster info. Okay, it says it's refused. Probably I have to log in as the root in order to be able to run it. Again, let's try kubectl. There you go. So it gives us the information of our cluster. Now if I also run kubectl get all, I'll give me the cluster IP. Are there any pods running? Get nodes, let's say. Yep, we have our control plane and it's still not ready. So the not ready, there could be possible reasons, so let's try to find out. Right, so as you can see here, there are a couple of system pods which are already running. The scheduler, the proxy, the controller, the API server, and the etc servers are running, but we still have our core DNS pending. So this is why our node, when we run this command, says not ready. So once they are up and running, then our node status will change to ready. Okay, so now let's go back to our previous SSH session. Now, so we have run this first command. Let's also run this command as a normal user. So let me exit. Okay, copy, enter, right? Let's see. Oh, my bad, sorry, there is a typo error. So as you can see the difference now, since we have given the permission, so our regular user can also run it. Previously we got the error that connection denied, you do not have sufficient permission, etc. Right? Now both our regular user and root has access and can manage the control plane or the cluster. Okay, let's go back. Right, the next step is we have to create a pod network for our cluster nodes to work and communicate amongst each other. Okay, so now let's go back to our script here. Okay, where is that section? Come on. Yep. Okay, let's follow this link. Right. So now under the Kubernetes documentation, we have networking and network policies. So these are the add-ons that are available. So I have a Calico for our lab, which I found quite convenient for me to proceed with. Probably we can try with the others, but for now we will stick to Calico. Okay, so if I right click on Calico and new tab, this is the Calico website. So if I click on get started, so this is a bunch of articles here. Now if I do install and upgrade, so if I scroll down and click on install on-premises deployment, so I can scroll down and I can see there are steps available. Okay, there you go. So you can refer to this document. So let's go back to our Visual Studio Code. So now I have picked up the URL that will help me to download the manifest file to be able to set up the Calico network, pod network. Okay, let me run this command on the other session. So that is downloaded, it's done, clear. Before we move ahead, there are a few things that we need to check on the config file here. So ls, there it is. So if I do cat, well, probably not a good idea. So let me do vim calico, okay. Let me copy this and come back to our vim editor and search. Okay, now as you can see here, my network for all the pods is 192.168.1.0. That's the network I'm using. In case I want to use the same network, I have to comment out. I can customize what range of what CIDR block I can use for my nodes. So for now, I'll just go ahead with the default. Okay. Now the next, after we have downloaded our Calico project YAML file, we are going to run the command apply. Okay, let me clear the screen. Oops, sorry. Right. This should not take much time. Perfect. So that is done. Now we can go back to check the status of our kubelet. Let me run a clear screen. That is active, running. Previously, if you remember, it was inactive and dead. Now it is back. So we can run the previous command wherein we found. Actually, we can run kubectl get nodes. As you can see here, previously, before our pod network was configured, it was set to not ready. Now it is ready. I'm going to run the another command which we use to check all the system pods. So let me, right. So now as you can see here, the core DNS that we're not running, now they are container creation in progress. So I can do watch, so we will know. Okay, well, it was too late. So now as you can see here, all the system pods are running. We have our Calico pod network pods, core DNS pods, etc, API, controller, scheduler, and proxy. Everything is up and running. Let's do a clear screen. Let me go back to the previous SSH session. So after we ran the kubeadm initialization, so these are the key steps, few steps that we have to take. One is run this command as the root as well as the regular user to be able to use or run the kubectl commands, followed by we use the link to download the Calico manifest file to create our pod network. Once that is done, our cluster is up. Now it's time. Now if I go back and run the command kubectl get nodes, it's only control plane node as of now. So now what we will do is we will SSH into our two nodes and we will run the commands side by side, so that as you can see here, we can run this command to be able to join the worker nodes. Now in case if you clear the screen and you lose it, there is a way to generate this token, which is here. Did I miss it? No, not. Probably down below somewhere I have copied. Yeah. So kubeadm ADM token create. So this will create the same token, not the same, it will generate it, and that can be used on the worker nodes to be able to join them to the cluster. Right, so now let's go back and do the same for all our nodes. So let me exit out of this guy, and I'll connect to 51, and I'll open another session to my second node, CP2. Alright, so let's scroll up. Now we have installed the components like container runtime, kubectl, kubeadm or admin or kubelet. All these components are also needed on the worker nodes, except for the pod network. Right? The rest of the remaining steps remains the same, from all the way from step number 1 up to here. Right? So up to here we have to run all the commands. So let's begin. I'm going to do it side by side so that we can make it quick, right? So let me run this command first in order to check. Okay, IP route. Okay, so this is 51 and IP route, so this is 52. Alright, the next is disable the swap. So I'm going to run this command on both the nodes side by side. So there I have to key in the password, which is fine. That is done. The same goes here, and key in the password. Right. Okay, the next step is to disable the swap partition. Okay, let me go to the section and comment it out. Yes, let's do the same on the second node as well. Yes, okay, that's done. Now the last step is forwarding. That's cool. Let's do the same here as well. Okay, that is done. We'll apply this setting without a system reboot. It's done. There you go. It's just back and forth. So if we know how to install the control plane, the same goes with the worker nodes as well. So I'm just repeating my steps here so that we can begin with the next phase of our journey with the Kubernetes cluster, that is deploying a sample app. Okay, so that should not take much time. I mean, I can skip the status check for container runtime, but in order to make sure that it is up and running, I'll just make sure check the status once it is installed. Okay, right, that's active. The same goes on node number 2, and that is active as well. Okay, let me clear the screen so that we can get rid of all the garbage on the screen here. Right, okay, so we have installed our runtime on both the nodes. The next step is to create the config file, the directory to host the config file for containerd. Okay, that is done. Now the next step is to make sure our systemc group is set. So this will require permission, of course, right? And that is done. Same goes on the second node. Okay, now the next step is to modify the file. So I'm going to copy our parameter, Control C, and open container, config the toml file, slash, search for it, hit enter, go into insert mode, and set the value to true. Let's save this file. That's done on node number 2. Let's do it on node number 1 as well. Let's see, container, config, there you go, insert mode, true, saved. Perfect. So now we have made the changes, so let's quickly validate by running this command. Over here it says true, here also it says true. I will quickly restart the container service. That's done, and that's done as well. Okay, let's update our app repository. That will take care of that. Same goes in here. Okay, next we are going to install the prerequisites for our other components. Okay, that is done. Enter. Okay, once that is installed, we're going to run this command so that we stay uniform with our Kubernetes version that we'll be using. Let me clear the screen first. Run it. Enter. The same goes here. Right. Clear. Okay, the next command is here. I've not entirely read through what this command is for, but it is available on the documentation. Feel free to read it to know more about it. Okay, that is done. Now it's time to run the update on the repository one more time on both the nodes, and done. We can run this command to check, but that won't be necessary for now. I'm going to skip it. Now it's time to install all the 3 remaining components on both the nodes, which is kubeadm, kubelet, and kubectl. Let's do it. Next we will check the status of our kubelet. Okay. Right, so let me clear the screen on, we are on node number 2. So let's check the status. It says inactive and dead. How about the other? That's still progressing. Now why it is dead? Let's open a SSH session to our master or control plane node and check kubectl, get pods, okay, that looks good, no problem. It still says inactive. Let's see, kubectl, get nodes. Of course, my bad, sorry. We have just installed the components, but we haven't made them as nodes to the cluster, right? Okay, yeah, sorry about that. Okay, for some reason looks like this is stuck or what? Okay, this is progressing. Right, while this is progressing, let's go back to our first control plane session, SSH session, and we copy this command. And go to our node which is ready to join the cluster. Copy and paste it and enter. Perfect. So as you can see here, this node has joined the cluster. So now if we do the command for check, it is active. Perfect. So clear the screen here. Now if I go back to my master or control plane node, and if I do get nodes, I can see it is not ready. Let me do again. It's still not ready. There you go. Let me clear the screen again. As you can see here, earlier we only had the control plane node. Now we have added the worker node 2 to the cluster and the status is ready. Okay, let's check the status of our node 1. Looks like node 1 is still busy. Right, so now since we have added one node to our cluster, we know the process, how we do it. So primarily we need to install all the 4 components on each of the node. That includes the control plane as well as the worker node, which is container runtime, kubeadm, kubelet, and kubectl. So once these are installed on the control plane, we run the kubeadm initialization to build the cluster. Once the cluster is built, we add the pod network, and we have a whole list that we can use to build, pick up our network for the pod. Calico is one I found suitable for this project, so you can also feel free to explore the others. I will be doing the same. Once that is done, we can run the kubeadm join command to join the nodes, worker nodes, to the cluster. Right, now since we have completed this, there is a pane here. As you can see, kubectl comes fine, but if I do get, it does not auto-complete our commands. Right, so let me adjust this a little bit. Okay, so this is important for pretty much everyone, so that the commands auto-complete. So now there is an article available inside the documentation on how to enable the auto-completion, so I'm going to run that in our control plane node. Let me key in the password. Perfect, so that is done. I'm going to run these 2 commands. The other one is for kubelet, and the other one is for kubectl, and the other one is for kubeadm. Enter. So that is done. Let me clear the screen and exit out of the session. That is closed. Let's open the session again. So I'm just reinitializing it. Now let me do kubectl. There you go. So it's now doing auto completion for me. So if I do tab, it's doing pod, or let's say, if just for test, kubectl create de deployment. Perfect. So let's just give it a name, hyphen image, and let's say nginx. Let me say dry run client port target. I did not mention a port, so target port. Right, so yes, we have our auto completion as well. So pretty much our control plane node is now ready to accept our commands, be it imperative or declarative, and we can go ahead and create our pods. So let me quickly check if it is doing. For some reason, looks like it is still doing, probably an internet issue. I'll not hold back on this since we already have one node. Let me get rid of a few of the SSH session here and drag it a bit to the right. Okay. Okay, so now first do kubectl get I need to close this session. I'm going to use it. Right. So I'm on my control plane node. kubectl get nodes. So we have one node available. kubectl get all. If I do, right now we only have cluster service, and if we do kubectl get pod, all namespaces, so we have only the system pods running. Let's create a pod as a test to complete our project of Kubernetes installation, cluster installation. kubectl run nginx image nginx and hit enter. It's created. So if I do now all pods, we can see it is creating a container or a pod for us. So let's do a watch until it's ready, or we can also do, there you go, it's now back to running. Now likewise, we have we noticed that there is a log command in Docker. Similarly, we have the same here as well. So kubectl logs, I can do pod nginx, so that's my pod. I want to check the logs off, hit enter. If I do, so it's giving me the information what exactly it is doing now. So as you can see here, it is ready, it's startup, so that looks good. We can also use to check the details of this pod, like kubectl describe command pod nginx, enter. So if I start from the bottom, so there are the events that are generated when the pod creation was in progress, such as it was assigned to which node, it says, pulling the image that we defined, that is nginx, successfully pulled the image from Docker Hub, created a container and started a container. If we scroll up, we can see the IP of this pod, which is 172.16.1041, and the node on which it is running. So it pretty much gives all the details, right? Now since it is internal IP, it cannot talk to my host machine, that is my laptop. So if I do simply this command, curl the IP, so that's the nginx HTML code, the welcome page. So now right now we are able to access it on the control plane node, and we should be able to access it from the worker node as well. So let's test it. So I'm going to go to 52. Right, so if I do curl IP, there you go, I'm able to access the nginx container or pod from both the nodes, the control plane as well as the node 2. Let me see. Okay, this guy is not happy. Alright, anyways, So that is running. Now, what if I want to access the Nginx from outside of the Kubernetes cluster? For that, I have to expose it. So let me clear this guy. kubectl expose pod, the name of the pod, type. There are details available on this different types of networking, that is node port, cluster IP, what they're used for. Please feel free to read about it. I'm not going to cover that here. Port 80, target port 80, and hit enter. Okay, now if I do kubectl command get all, previously, if you recall, we were only seeing one service, that is our cluster IP service, the Kubernetes service, right? Now we have Nginx also. So there is a port assigned. Now I know the IP address of my control plane. I'm going to use it to see if I'm able to access it from outside the Kubernetes cluster. The pod, the Nginx pod precisely, can we access it? 302.1.7. So if I come in here, and I do 50, did I type in there? Be right? Oh, my bad. 217. Yo, there you go. So with the help of the command expose, now we are able to allow the pod to be accessed from outside of the Kubernetes cluster. So that's how we can do it. Now let me just check. So as you can see here, yeah, these are some of the basic commands that you can use. Now since we have tested our cluster setup, it is working, we are able to create pods. In the next video, I'm going to do the same test, that is while learning Docker and Podman. I've tested the voting app. Likewise, we are going to build the voting app on our own in Kubernetes cluster. For now, to end this video, I'm going to get rid of this pod and the service. Now the command to delete, if I type in, since we have the autocomplete enabled, I do tab twice and that automatically pulls the command delete. I'm first going to delete the pod, which is Nginx, delete it. Next I'm going to remove and say service Nginx, done. Now if I do kubectl get all, I see none. And if I do the same, kubectl get pods, all namespace, as you can see here, we only have the system pods running, and the test Nginx pod we created is gone. Well, this guy is unhappy, but the process is the same. Using the same kubeadm join command followed by the token, we can add number of nodes to the cluster. And to check the status of all the nodes, we can use this command kubectl get nodes. Sorry, on the wrong guy. So kubectl. Right, so we should be able to see the status of each and every node added to the cluster as ready or not ready. The one which is ready, the API can talk to and can deploy pods. The one which is not ready could be it's not available. Yeah. So thank you for viewing. I hope you find this video informative. Probably while creating this video, I will try to upload these steps in the description so that when you have time and you want to build your own Kubernetes cluster in your home lab to do to gain hands-on practice, then you can use these commands and build your Kubernetes cluster easily. Thank you for viewing and have a good day.